During the most recent heatwave in August, I had a discussion with my wife on whether or not we should investigate in a mobile airco station. I was in favor since I don't cope too well with this heat. However, she had the last word, saying, well, we could only use it a few days in the year, so it won't be a good investment. Now, I just had a look at the temperature outside and it says 31 degrees. Maybe I should reopen that discussion. It's quite remarkable, however, that we are not really surprised anymore when we see these kind of temperatures. We have seen an increase in the frequency and intensity of extreme weather events. Think of the catastrophic forest fires in the US, in Australia, but also in Europe we have witnessed extreme heat waves in the last 5 years. In addition, according to recent studies, the planet is warming up by 0.2 degrees per decade. This suggests that things will only get worse in the near future. So countries, organizations, governments, they need to organize themselves to fight this climate change. Enter, for example, the Paris Agreement and the European Green Deal. The European Green Deal is the ambitious plan of Europe to make it the first climate-neutral continent by 2050. In fact, it's the European Commission answer to the Paris Agreement to keep global temperature rise well below 2 degrees compared to pre-industrial times. Now, the European Green Deal consists of 7 strategic building blocks, which you can see here. For example, maximizing the benefits of energy efficiency, including zero-emission buildings. Pursuing these building blocks will allow the EU to move to a prosperous climate-neutral economy. Now, what has this all to do with my talk of today? In June 2019, almost 200 airports in Europe have signed the Net Zero Carbon 2050 resolution from ACI Europe. This commitment engages the whole European airport industry to eliminate its carbon footprint at the latest by 2050. The same ACI also conducted a study to investigate the main drivers of CO2 emissions by airports. Now, we see them below. First of all, we have electricity consumption, predominantly for heating, cooling, lighting, and servicing terminal buildings and other buildings managed by airport operators. Secondly, boilers, mainly for heating purposes of these buildings. And then, of course, we have vehicles and support equipment running on petrol, diesel, or gas. Now, it's important to note that this data doesn't contain the CO2 emissions by airplanes, because airplanes are operated and managed by airlines and not by airports. So we have a clear goal, a net zero, and a rough view on the main drivers an airport can work on. Now, since a goal without a plan is just a wish, there is a clear need for a well thought out approach. This is where an energy management system can be used for. In order to prevent all companies to find their own energy management system, the ISO has defined an international standard called ISO 50001 for energy management. It is designed to support organizations in all sectors and provides a practical way to improve energy use through the development of an energy management system. In order to obtain such a certification, companies basically have to follow a 6-step approach, taking the classical plan, do, check, act cycle into account. First, you have to develop a policy, fix some targets, use data, measure the data, review the policy, and then eventually work on a continuous way to improve energy management practices. In light of today's session, I'll focus on steps 3 and 4 and use data and make meaningful insights and measure results to see where we are. So, my name is Frederik. I'm working for DXC Technology as a senior consultant within the energy and technology practice. Since a few years, we have been partnering with Opinum in the field of energy management and solutions related to smart meter data. We also partnered together for the reference case I will talk about today. Due to confidentiality reasons, we are not allowed to disclose the name of our client, but by the introduction, it should be clear that our client is in the aviation industry, more specifically in building management. Our customer was awarded an ISO 50001 certification a few years ago. A key objective for the customer was to extend the certification. After an interim audit, they received clear instructions to update and upgrade their current way of energy management. At that moment in time, they used loads and loads of Excel files filled with tables, graphs, and complex formulas. Needless to say, this is quite error-prone. Therefore, our client wrote out an RFP with the goal to implement an energy management and monitoring system. DXC Technology and Opinum were not the only one to compete in this procedure. However, out of numerous candidates, DXC and Opinum were awarded the contract to deliver the EMS. So the key objective was not only to extend the ISO 50001 certification, but the company was also really interested to start measure, analyze, and manage the energy consumptions and identify and evaluate energy saving measures on the site. The customer itself has identified a number of groups of use cases, which you can see here. The following 6 are non-exhaustive list, but to give you some examples, for the consumption data, they wanted to follow the consumption data of the complete site, of separate buildings. For the energy balance, they wanted to know the primary energy usage, the energy usage per square meter, the total emissions of CO2. They wanted to have a clear reporting mechanism. In case of anomalies, they wanted to receive some alerts. So each of these use cases contains a subset of use cases. Now, it's needless to say that we couldn't tackle everything at once, so we have decided together with the customer that we'd work in a kind of MVP mode, a minimal viable product, where we would select 2 basic use cases. So for the MVP, we decided to work in the first stage with electricity and heat meters. For electricity, we would receive the active energy, and for the heat meters, we would receive the cumulative indexes. It is important to know that the metering data will come from 2 separate head-end systems. So we will receive the data from the meter through 2 separate head-end systems. For the first use case, we have decided to model a first building. It's a recent building equipped with quite some smart meters, which makes it interesting, of course. And then for the second use case, we have decided to model the actual energy balance of that building. So what does the solution look like? It's what you can see here. On the left-hand side, we have the meters, electricity and heat that communicate 50-minute values to an intermediate head-end system. And the head-end system transfers the data on a daily basis through an FTP towards Opinum. And then we do our magic in Opinum, and we have in the Opinum Data Hub, and then we could see some dashboards, reports, etc. Now, what is in scope of our project? It's the part where we receive the data, we do the configuration and some basic calculations in Opinum, and of course the building of the dashboards and the reports. What is not in scope is the data coming from the meters towards the head-end system and the sending of the data from the head-end system towards Opinum. So we will also not do any validation or checks on the values and on the meter data we receive. We assume they are correct and validated. So what's under the shell of what I said before? We do our magic. We have a number of functional blocks in our solution. They consist of the asset data and the meters. We have the meters need to be known in the solution. We need to be able to capture the metering data. I said before, there is an alerting functionality. We have some basic dashboards that we want to create. And of course, there is a user management, defining which user can have access to which site, to which dashboards, etc. Now, in order to do so, we have defined a multi-step approach. So first of all, we have decided to work with a standard product and to keep it out of the box. So there is no separate development layer that we've put on top or aside. We just use the basic functionalities coming out of the box available from the Opinum Data Hub. So first of all, we have to define the basic architecture. This includes making decisions on what we are going to use as a site, as a source, as a variable. And in our case, we have decided to use for sites actual buildings, and for sources the physical meters within these buildings. There is a little exception here, for example, for concessions. as we are not allowed to see the data from each of the concessions. So we will aggregate these data, so we will use virtual sources and not physical sources or physical meters. And then regardless of whether it's a virtual source or a physical source, we receive raw variables from the third-party head-end systems I've just shown before. So first of all, the basic architecture that we have decided how we want to work. Now the second step is the meter integration. For our sources, we have a basic set of data that's right available in Opinum that we can define as metadata in our system. Now, we have found that this was not enough in our case, so we have created an own custom form, which you can see here, where we added some additional fields. For example, the meter location, the source system, the floor number, is it a significant consumer, what's the model, so all sorts of additional information that is not foreseen in the standard form, but which we can easily configure through the Opinum Data Hub. Now, rather than configuring all these meters one by one, you can imagine we have numerous of buildings with a lot of meters. This takes a lot of time. There is, of course, an automated way to do so. So we use the Excel functionality that comes standard out of the box with the Opinum Data Hub, where we can just fill in an Excel file after we have created the template, and this will automatically match the values we've put in the Excel file into the Opinum Data Hub. So we have our basic architecture, we have defined our meters, start to create our meters within the Opinum Data Hub, first by creating hand by hand, but also by using the Excel template. The third step is then to have a data upload. I've indicated before that we will use an FTP or to transfer the data from the head-end system towards our system. This is actually something that Opinum took care of to set up the basic file transfer. Next to this, we have defined some basic naming conventions on how we should receive the data, what the name or the names of the files should be. This is to map the data coming from the files from the third-party head-end system into the Opinum Data Hub. Here you can see, for example, the triggers we have defined. So if a value or if a file is named according to certain rules, the data will be mapped towards a certain meters into our system. So after we have the basic architecture, our meters in our system, we have defined how we will receive the data. It is important to start processing the data once we receive them. So as mentioned before, we received the raw variables in kilowatt hours, either active energy or indexes, and we can use this data to create additional variables. Our data scientists have used the out-of-the-box available modules, either Python or R script, to create these. For example, we have created a calculated variable for the cumulative index to calculate the actual energy consumption. In addition, we added some interpolation, so in case a data value is missing, that we are able to fill in the gap. Another example is the calculation of the actual primary energy based on the energy consumption. We created a virtual source which combines all the data from the whole building, and then on this source we created additional variables to do some derived calculations. For example, we transferred the kilowatt hour value into megajoule following the standardized conversions. In this case, for electricity, 1 kilowatt hours equals 0.009 gigajoule. The primary energy allows us to easily calculate the CO2 emissions according to same standardized conversions, but also allows us to calculate the primary energy consumption per square meter of a building. So after we have our data processing done with our calculated variables, we can start to create some dashboards. This can be done through the dashboard section or the reporting section. For our building, we have identified a basic set of information dashboards that give some insights in the blink of an eye. More in-depth dashboards and reports are available, for example, to calculate the earlier mentioned CO2 emissions of the building. For example, here we can see a dashboard for a set of meters within a building. We could also define a dashboard on a building level. Now, I blurred some things because, as I mentioned before, we cannot disclose any of the information. But it should be clear that it is possible to draw meaningful insights based on the information we captured through the meters and the calculated variables. And as I said, we can also do a reporting through Excel. So on a weekly basis, we could send reports. And for example, you see a screenshot of the electricity consumption of a certain part of a building. So last but not least, we also have user management and the creation of alerts. Both sections speak for themselves. Within the user management, we are able to easily identify who gets access to which sources and which sites, and who can see which dashboards, who can create the dashboard, etc. And the alerting section allows us to get informed in case of anomalies. Unfortunately, the worldwide COVID pandemic forced us to stop abruptly. With this project. Due to different national lockdowns across Europe, the aviation sector got hit hard. Activity fell drastically, and so our project was temporarily put on hold. Luckily, this gives us enough time to start working out several new use cases. Since we are almost at the end, this gives me the time to thank my fellow team members for the hard work, flexibility, and willpower to make this project a success. So Thea was the functional lead and the data scientist who took care of all technical parts of the project. Jan is a functional lead who made sure that we could transfer or translate the desires and the requirements from our customer into Opinum Opinum Data Hub available functionalities. And then from Opinum, we had the help of Patrick Watene, who acted as an Opinum expert and took care of the backend setup for the file transfer, for example. So before we move on to the Q&A section, let's have a small recap. DXC and Opinum were chosen to deliver an energy monitoring system in the light of an ISO 50001 certification renewal. We entered in a close partnership with Opinum and our customer with a commitment on results, so it was a fixed price. We worked with a minimal viable product where we selected 2 use cases to bring added value in the short term, and this has proven its value, by the way. There was a shutdown and a non-restart of a machine which has been identified through the dashboard. We were able to deliver very fast. It's only a matter of weeks rather than months, due to the usage of several agile best practices and the strong attention to co-creation. And last but not least, we had a small but dedicated and motivated team consisting of the technical lead, the functional analyst, a project manager, and the Opinum expert. So this concludes my talk of today. In case you have any more questions, feel free to reach out through mail or LinkedIn, or of course through Opinum. By now, I should have had the chance to answer most of your questions. But if not, feel free to reach out through one of these channels. Thanks in advance, and I hope to see you on the Opinum conference of next year. Bye.